In this video, we'll learn what imaginary and complex numbers are. Complex numbers are made up of two parts, a real part and an imaginary part. So let's say we have the complex number x. X will be in the form of a plus bi, where a is in the reals, b is in the reals, but I is equal to the square root of -1. And now that bi is an imaginary number. So basically what an imaginary number is that it's a complex number that can be written as a real number multiplied by the imaginary unit I, which is defined by its property I equals square root of -1. Okay, so basically it's saying that x is a plus b times square root of -1. Now that is an imaginary number, or a complex number actually. So if you are given a question asking to identify the real and the imaginary part of a complex number, let's say we were trying to find the real part and the imaginary part of this imaginary number a, it would be 2 plus, say, 3i. You would say that 2 is the real part. You write it as re, bracket a, close bracket, and you write im, open a, close a, equals 3i. That would be like one of the questions in your exam. Let's try another one. What if we had 3i minus 2? What would be the real part and the imaginary part be? The real part is the number that doesn't have I multiplied to it, so it's -2. Now the imaginary part is the number that has I multiplied to it, so it's 3i. Easy. Now there are some interesting facts about I. I is the square root of -1. Now what happens if we square I? So I squared, that's that. So the square root and the square cancels out and it becomes -1. Now what about I to the power of 3? So I cubed. I cubed is equal to I squared times I. So it's -1 times square root of -1. So it's negative square root of -1, which is -I. We didn't have to do it. We didn't have to do that step, but oh well. So that's -I. Now what about I to the power of 4? That is equal to I squared squared. So that's -1 squared. It's 1. Now let's have a look at I to the 5th power. That will be I to the 4th times I. So that will be I. I to the 6th is I to the power of 5 times I, which is I times I, -1. I to the 7th is I to the 6th times I, -I. And I to the 8th is I to the 4 squared. So that's 1 squared equals 1. Then you see the pattern here. So I is equal to I to the 5th. I squared is equal to I to the 6th. And I to the power of 3 is equal to I to the 7th. And I to the power of 4 is equal to I to the power of 8. So what you see here is that the powers of I follow a circular pattern. So it basically goes from I, then it goes to I squared, goes to I to the power of 3, goes to I to the power of 4, and back to I. Okay, and that would be, if the circle would go on forever, that would be I to the 5, I to the 6, I to the 7, I to the 8, I to the 9th, and so on. Now you can see how the powers are going up by 4s. That's plus 4 and that's plus 4. That's also plus 4. That's also plus 4. And that is also plus 4. So if looking at this pattern, we know that I to the power of n is equal to I to the 4 times a plus m, and that is equal to I to the m. And basically what this part is doing is that it's dividing n, so dividing n by 4, and it's finding the remainder, m. So m is the remainder. We divide by 4 because the pattern goes up by 4. Okay, I'll explain this through an example. Let's say we had I to the power of 14. Our first step is to divide 14 by 4. Then we have 3 remainder 2. So we can write this as I to the power of 3 times 4 plus 2 will be equal to I squared, which is 1. Now, this 3 here means that we do 3 full rotations of the circular pattern of I. So let's say we had I squared, I to the cubed, and I4. And the 3 is saying that we do 3 full rotations of the circle, and we always start at I equals 4, because that is equal to 1, and 1 is our starting point. So let's do it. We're doing 1 rotation, 2 rotations, and 3 rotations, and we go another 2 spots. So we go 1 and 2, and we end up at I squared. So that I squared is equal to I to the power of 14, which is what we did here through our formula kind of thing. Okay, let's try one more example. Let's say we had I to the power of 27. First step, divide 27 by 4. That will be 6 remainder 3. So I 6 times 4 plus 3. That's equal to I to the power of 3. If we were to do the circle thing again, that would be 6 full rotations. So 1, 2, 3, 4, 5, 6 plus 1, 2, and 3, and we end up here.